Hello students, we'll continue our discussion of biomolecules. Today we are going to start with lipids. Okay. Now what basically are lipids? Lipids are basically a group of molecules which are insoluble in water. Okay. Which are insoluble in water. So there are a variety of molecules which are insoluble in water, and all of them combined gives you lipids. Okay. So the types of lipids, the types are important. What are the exact types? The first type is known as fats and oils. Okay. The second type is known as phospholipids, and the third type is known as steroids. Okay. The third type is known as steroids. Okay. Now let us start with fats. What exactly is a fat? Okay. Fat essentially means uh, glycerol plus fatty acid. Glycerol plus fatty acid essentially gives you fat. So basically what you have is a backbone of glycerol. You have a backbone of glycerol, and to this backbone fatty acids are attached. Okay, we usually have 3 fatty acids attached to this backbone. Okay, now let me just tell you one by one what exactly is glycerol and what exactly is a fatty acid. Okay, so first and foremost, what is glycerol? What is a glycerol? Glycerol basically means a molecule of 3 carbons. Okay, glycerol has 3 carbons, and each carbon has a hydroxyl group. Okay, each carbon has a hydroxyl group on one end, and on the other hand, you have hydrogen to make the valency correct. Okay, this is glycerol. Now, to this glycerol, you add fatty acid. Now, what exactly is a fatty acid? Fatty acids are basically long chain carboxylic acids and nothing else. Long chain carboxylic acid. Now, what exactly are long chain carboxylic acid? What do you mean by that? Long chain carboxylic acid. What do you mean by long chain carboxylic acid? So, normally what happens is that carboxylic acid has the formula RCOOH, right? That is the general formula. Now, if this R group contains between 10 to 20 carbons, okay, then definitely it's a long chain carbon, right? Okay. Now, fatty acids, fatty acids mainly has 2 types. Okay, the first is known as saturated fatty acid. Now, what exactly is a saturated fatty acid? So, if you take the carboxylic group, okay, COOH, this is the carboxyl group, right? Now, if the R group, suppose this is the R group, okay, if the R group does not have any double bonds, then this is known as saturated. Okay, if by any chance, if the R group has a double bond, then this is known as what? Unsaturated fatty acid. So in case of unsaturated fatty acid, you have a carboxylic group, okay, and along with this carboxylic group, you are going to have an R group, and this R group will contain a double bond somewhere. Okay, it is going to contain a double bond wherever it may be, but it will contain a double bond. All right. So these are the 2 types of fatty acids that you'll see. Now, from these two, from glycerol and fatty acid, you will have to make a fat. Now, what exactly is a fat? Just let me tell you. Okay. Now, a fat will contain a skeleton of glycerol. Okay. It is going to contain a skeleton of glycerol. So, what is glycerol? How does it look like? 3 carbon skeleton. Okay. Along with 3 OH. Okay. CH2, CH, CH2. Okay. This is glycerol. Now, let me just show you an example of one fatty acid. Suppose this is one fatty acid, COOH, right? And you have an R group. Okay, you have an R group. Okay, R group may be between 10 to 20 carbons. Okay, now what basically is going to happen is that the H from this glycerol and the OH from this fatty acid, they are going to escape by forming water. Okay. Now, what basically will make this happen is that there will be a bond formed between this carbon and this oxygen. Okay, there will be a bond formed between this carbon and this oxygen. So, let me illustrate this in the second type. Okay, so what is going to happen? There will be a bond formed. Okay, suppose this is the bond here. Okay, and this is going to get formed between the carbonyl group and the glycerol. All right, this particular bond that is formed, this particular bond that has been formed, this is known as the ester bond. This is known as the ester bond. So all three, okay, all three carbons are going to form ester bonds. They are going to form ester bonds with fatty acids. Right? So ester bonds. Right? Okay. This is also going to form ester bond in the end. Okay. So this in the first on the first segment, I've just shown you the example. Just shown you how the mechanism is, but eventually even this is going to form this bond. Okay, make no mistake about it. So you're going to have 3 ester bonds, which joins 3 fatty acids to glycerol. Is this point clear? Right? Okay. So this is fat. Okay. Now the basic difference between fats and oil is that, okay, if I draw oil, okay, this is also glycerol plus fatty acid. Okay, this is also glycerol plus fatty acid. The only difference is that these fatty acids are primarily unsaturated. Okay, but in case of fat, more or less most fatty acids are saturated. It means that this does not contain any double bond. But in case of oil, most fatty acids are unsaturated. That is the only difference between fat and oil. Otherwise, they are the same. Okay. Next comes phospholipids. Now, phospholipid has a structure very similar to that of glycerol. Okay, they have a structure very similar to that of glycerol. So if I draw a glycerol, okay, now let me add fatty acids to it. Okay, let me add a fatty acid, just a second. Okay, so if I add a fatty acid, for example, if I'm adding it here, okay, right, so I'm adding fatty acid by ester bonds, right? Okay, so this is a proper fat, right? This is a proper fat. Now if I replace one of these fatty acids, if I start to replace one of these fatty acids by a phosphate group, okay, Let me just replace one of these fatty acids by a phosphate group. So instead of CO, let me just write PO. Okay, let me just write it this way. Suppose this is phosphate, PO4. This is phosphate. Now, along with this, if I draw a variable, okay, if I draw a variable which is also known as X, okay, this X is what? This is a variable. Okay, now this becomes a phospholipid. Okay, it has a phosphate group here. Instead of an ester bond, you're going to get a phosphoester bond. Okay, now what I mean by this variable is that just like the R group in amino acid, okay, the value of X is going to depend is going to govern the name of the phospholipid. Okay, depending upon what the value of X is, you're going to get different types of phospholipids. One such example is given in your NCRT. Okay, so one example is given wherein uh, the name of your phospholipid is given lecithin. Okay, so in case of lecithin that has been given in your NCRT, okay, it's given there in your NCRT. The structure is given there. You can look at it carefully. Okay, the structure of lecithin, X is equal to CH2, CH2, N, CH3, CH3, CH3. All right. So if you look at the structure, if you go through your NCRT, see this alkyl chain is represented as R. Okay, this is the R group. Suppose this is R1. This has been represented as R2. Right. And this particular variable, instead of X, just place this molecule. Okay. So what becomes? The phospholipid then becomes lecithin. Okay. Lecithin is a type of phospholipid. Okay. It is a type of phospholipid. Clear? Okay. So this is phospholipids. Lastly, you have sterols. Okay. Lastly, you have sterols. Now, sterols are basically structures having four fused rings. It is basically essentially a structure of four fused rings. Out of these four fused rings, three rings have 6 carbons and one ring has 5 carbons. So any sterol that you see is going to have a ring like this. Okay, they will have a structure similar to this. So these are three 6 carbon rings, and then you're going to have a 5 carbon ring. So this is a steroid nucleus. This is also known as steroid nucleus. So any sterol, okay, any sterol that you see, you will always find this nucleus. Okay. Now one such example of steroid is cholesterol. Okay. Cholesterol is an example of one such steroid, and it is also given in your NCRT. So just like any steroid, cholesterol is also going to have four fused rings this way. Okay. Now apart from this, there are certain add-ons. For example, you'll also have an OH group on one side. Okay. On the other side, you're going to have an extension this way. All right. And in between, you're also going to have a double bond somewhere. So in total, cholesterol has around 27 carbons. It has what? 27 carbons. And this is the structure of a cholesterol. Okay. Another thing that I'd like to mention is that in NCRT, this particular structure, okay, the structure of fat has been mentioned as triglyceride. Okay, so if this structure comes up, okay, it has not been mentioned as fat, rather than that, it has been mentioned as triglyceride, wherein the alkyl chains are represented by the letter R. This is R1, this is R2, and this is R3. So please don't get confused. Okay, triglyceride is essentially nothing but fat only. They are fats only. Okay, so this more or less concludes our video for lipids. We will come back with another lecture for enzymes very shortly. Thank you so much.